In this next module, we're going to look at another measure of association called a relative risk. Instead of subtracting the risks in the different groups, what if we instead divided them to make a ratio? That's called a relative risk. There are several measures of relative risk, and relative risks appear very frequently in the medical literature. If you take two incidence rates and divide them, that's called a rate ratio. You'll also see something in the literature called a hazard ratio. A hazard ratio is also a ratio of incidence rates. It's just a ratio of what we call instantaneous incidence rates or hazard rates. Hazard ratios actually come from a regression technique that we're going to talk about much later in the course. But for now, you can just interpret them exactly the same way you would interpret a rate ratio. If you divide two cumulative risks or two prevalences, we call that a risk ratio. Now, some people might call the ratio of two prevalences a prevalence ratio to distinguish it, but I tend to lump them together and call them all a risk ratio because cumulative risks and prevalences are both just proportions. Another measure of relative risk I'm going to talk about a great deal this week is something called an odds ratio. An odds ratio is a ratio of two odds, and I'm going to have to tell you what an odds is in a minute because you may not really understand what an odds is already. But the odds ratio comes up a lot in the medical literature for two reasons. The odds ratio is the only valid measure of relative risk for case control studies. That's one reason. The other reason that odds ratios come up a lot is that a lot of researchers want to do a regression technique called logistic regression. It's a multivariate regression technique that's used when you have a binary outcome and you want to adjust for confounders. It turns out that logistic regression gives you out odds ratios. So even if you're doing a cohort study or a cross-sectional study, if you use logistic regression, you're going to get out odds ratios. So odds ratios are all over the literature, but as we're going to see in this module and the next module, they're a little bit of a funny measure and sometimes they're tricky to interpret. So how do we interpret relative risks? So the rate ratio and the hazard ratio you can interpret as the percent increase or decrease in the rate of the outcome. The risk ratio is the percent increase or decrease in the risk or prevalence of the outcome. The odds ratio is the percent increase or decrease in the odds of the outcome. And again, I'll fill you in on what an odds is in a minute. If you have a relative risk that's equal to 1.0, that means that the risks in the two groups are equal because, say, if the risk is 20% in one group and 20% in the other group, if you divide 20% by 20%, you're going to get 1.0. So that represents where there's no difference between the groups. We call that the null value. If you have a relative risk that's less than 1, that indicates a protective effect. Whatever was in the numerator is protecting you from the outcome. If you have a relative risk that's greater than 1, that indicates a harmful effect, an increased risk. Let's calculate the rate ratio first, starting with the GI event data from the Vioxx study we've been talking about. Incidence rates were 2.1 and 4.5 again. All we have to do here to make a rate ratio is to divide the two incidence rates. And notice because we're dividing two rates, the units here, the 100-person years, actually cancels out, and the rate ratio doesn't have any units, it's unitless. We come out with a rate ratio of 0.46. The interpretation is that Vioxx reduces the rate of GI events by 54%. I got that 54% simply by subtracting 1 minus 0.46. So that's a 54% reduction in the rate of GI events. If I want to calculate the risk ratio for these same data, I'm just going to divide the risk in the Vioxx group by the risk in the naproxen group. Interestingly, I get exactly the same number here, 0.46. So in this case, the rate ratio and the risk ratio are identical because remember, the person years of follow-up was exactly the same in both groups. So if you're following people for the same amount of time, then the risk ratio and the rate ratio will come out to be the same. However, if there was a differential follow-up between the groups, then this wouldn't be the case, because if one group was followed for longer than the other group, that would increase the risk in the group that was followed longer, and it would change the risk ratio compared with the rate ratio. Now I want to read to you what they put in the paper's abstract. During a median follow-up of 9 months, 2.1 confirmed GI events per 100 patient years occurred with the rofecoxib, that is the Vioxx group, as compared with 4.5 per 100 patient years with naproxen. Now they're going to give the relative risk. The relative risk is 0.5, so they rounded up from 0.46 to 0.5. 95% confidence interval, 0.3 to 0.6, and it's highly statistically significant. I want to spend just a minute here to walk you through what that confidence interval means. We're going to spend a lot of time on confidence intervals in an upcoming week of the course, but I want to just give you sort of a conceptual understanding of what that confidence interval means here. So the relative risk that we calculated in the study, what we call the point estimate, what we calculated in the study was exactly 0.46 rounded up to 0.5. So that indicates a halving of risk. But that's just what we saw in the study. And of course, whenever we do a study, we know that there's going to be some uncertainty. In other words, the true effect of Vioxx on GI events might not be exactly 0.5. We understand that when we do a study, there's uncertainty. We have to put a margin of error around our estimate. That margin of error is what we call the 95% confidence interval. So the 95% confidence interval here is 0.3 to 0.6. That gives us a plausible range of values for the true effect. The real effect of Vioxx on GI events, we believe, is somewhere between 0.3 and 0.6. Another way to interpret it is we say we can be 95% confident that the true effect of Vioxx versus naproxen is between a 40% and 70% reduction in the rate of GI events. Where did that 40% and 70% come from? The upper limit of the confidence interval is a relative risk of 0.6. That's a 40% reduction in risk. The lower limit of the confidence interval is a relative risk of 0.3. That's a 70% reduction in risk. Now let's move to the heart attack data from the study. What's the rate ratio going to be here? The rate ratio will be the rate in the Vioxx group divided by the rate in the naproxen group. When you do that division, it comes out to be 4.2. For the risk ratio, it's actually identical, as I said before, because the groups were followed for equal amounts of time. The risk ratio and the rate ratio are the same. How do we interpret these results? We would interpret this that Vioxx increases the rate or risk of heart attacks by fourfold, or you would say by 320%. But let's see what the authors actually put in the abstract here. So here's the abstract from the paper. The incidence of myocardial infarction, heart attack, was lower among patients in the naproxen group than among those in the Vioxx group. 0.1% versus 0.4%. We already saw that number in the last module. Relative risk 0.2, 95% confidence interval 0.1 to 0.7. So notice that when the authors reported the data on GI events, they put the naproxen in the denominator. They put the naproxen as the reference group, but when they report the data on heart attacks, they're flipping things around. They're making Vioxx the reference group. They're putting Vioxx in the denominator, and you can probably think of the reason that they might have wanted to do that. So there are actually two funny things going on here, as I alluded to in the last module. So firstly, they reported risks rather than rates. For the primary outcome GI events, remember they actually reported the incidence rates. They reported the risks here likely because the risk difference looks smaller than the rate difference. Secondly, they flipped the relative risk. They divided the risk in the naproxen group by the risk in the Vioxx group rather than the other way around. So remember, the risk in the Vioxx group was 0.42. The risk in the naproxen group is 0.1. If you divide 0.1 by 0.42, you get a relative risk of 0.24. And they rounded down in the abstract to 0.2. They rounded to 1 decimal place. So they've twisted the message here, right? They've twisted the message to make it look like naproxen is protective rather than that Vioxx is harmful. And technically, they haven't done anything wrong mathematically. The numbers are correct. But flipping the relative risk, of course, completely shifts the take-home message. And people missed it. Not one person wrote a letter to the editor of the New England Journal after this article was published questioning the author's logic here. People bought into the story that the authors were trying to sell, that naproxen is this miracle heart protective drug, instead of that Vioxx is a dangerous drug. Here's what they wrote in the paper's conclusion. I showed you this in the teaser earlier. Thus, our results are consistent with the theory that naproxen has a coronary protective effect and highlight the fact that rofecoxib Vioxx does not provide this type of protection. The finding that naproxen therapy was associated with a lower rate of myocardial infarction needs further confirmation in larger studies. Of course, naproxen is the reference group, the control group in this study. So every comparison really ought to be Vioxx versus naproxen, not naproxen versus Vioxx. But they totally put the focus on naproxen to take the focus away from Vioxx, and it worked. In fact, it turns out that naproxen has a very small, if any, cardioprotective effect. So here was clear evidence sitting in the literature in 2000 that Vioxx raises the risk of cardiovascular events. Some people think that if people had actually looked at this study more carefully and kind of questioned the reasoning of the authors here, that Vioxx might have actually been pulled off the shelves sooner than 2004. The data we're sitting here showing us that there's this cardio harmful effect of Vioxx. And there's actually a lot of backstory here that I'm not telling you. There was actually some data omitted from the New England Journal of Medicine paper. If you're interested in all this, you can Google it and you can find out more about the story. People made a big deal about the fact that some of the heart attacks, there were actually 3 heart attacks that probably should have been included in that New England Journal paper that weren't. But in fact, the data that was already available in the paper really told the whole story. It's just that the authors had managed to spin that story and people bought it. So the bigger lesson here is that it's very important when you're reading a medical paper to always look at the data yourself and interpret the data yourself. Because if you allow the authors to lead you through their interpretation of the data, you can easily get sucked into the story they want to tell you. And that's what happened here.